What we, for the sake of convenience, call a chip is officially called an IC, the abbreviation for integrated circuit. A chip is like a city with no people but bursting with activity. A chip is packed with industrial buildings, control centers in the form of components such as transistors and resistors, which together form one huge network. The chip's infrastructure carries vast amounts of fast traffic along roads and communication networks. The building blocks in chips are not only becoming ever smaller, but our designers are also making the chips cleverer all the time, so as to create new possibilities continuously. This makes the equipment controlled by these chips better, safer, easier to operate, more energy efficient, and friendlier to the environment. Let's stride in 7-league boots through the ingenious process by means of which products such as chips are produced at Philips Nijmegen. We'll explain aspects such as the most important steps in the production of ICs, and to make this easier to understand, we'll begin with a series of animations. A chip is an extremely small silicon plate, ranging from a couple to several dozen square millimeters in size. This tiny silicon plate is then filled up with a great number, sometimes millions, of microelements such as transistors, diodes or resistors, which together form an integrated circuit, the IC. We make a large number of chips all at once on a round silicon disc called a wafer or slice. First of all, we create a new layer of silicon on the slice, 1/100th of a millimeter thick. We then oxidize this silicon layer in an oven, so that an even thinner insulating layer is created on top of it. We then apply a coat of light-sensitive lacquer. We expose the lacquer through a kind of photographic negative, so that the lacquer dissolves in certain places. Then, in the places where there is no more lacquer, we shoot atoms with great accuracy through the oxidized layer into the silicon. The layer of lacquer is then no longer required and is therefore removed from the slice. We then ensure that the atoms penetrate a little deeper into the silicon by a few thousandths of a millimeter. A new silicon layer is applied over the oxide layer. And once again, a layer of lacquer is applied, exposed, and developed. The silicon which is uncovered by this process is then etched away. Another series of treatments involving lacquering, exposure, bombardment with atoms which penetrate the silicon, new oxide layers, etc. is performed until the whole pattern is complete in all its layers. Some 300 to 400 process steps are required, along with 15 to 20 different masks with microscopically small patterns. The final step in the process is the connection of the various, almost invisible, tiny elements in the silicon. This is how we make an electronic circuit, an IC or chip. Naturally, we have a particularly good relationship with our suppliers, as they too play a part in determining the final quality of our products. Silicon is made from ordinary quartz sand, and rods of silicon are then created, or drawn, at extremely high temperatures. Thin slices are then sawn off these rods with great accuracy. The ICs will be produced on these slices of silicon, for which purpose the slices will undergo 300 to 400 processes. The first step in the production process is as follows. In this special oven, the slices are covered by a new thin layer of very pure silicon, into which the transistors and other components can be built. The slices with a new layer of silicon are placed in other boxes, where the silicon is allowed to oxidize. This insulating oxide layer can be removed at a later stage when necessary. These are known as the yellow rooms. Here, extremely intelligent, fully automated machines are used to apply the light-sensitive layer of lacquer to the oxide on the slices and to expose the slices. Yellow light is used in these rooms, as the lacquer is not sensitive to this. The patterns on the masks, a kind of photographic negative, are of course designed by our own development engineers. The templates themselves are made by other specialists. It goes without saying that we also cooperate very closely with these suppliers and equipment manufacturers. In these so-called implanters, specific atoms can be shot into the unprotected areas of the silicon to give them a positive or negative conductivity. This is done incredibly accurately. For example, 1 atom in 100,000 silicon atoms. One of the next steps in the process is etching, removing material locally from the slices with great accuracy. This department uses an automatically controlled process involving acids and caustics. Another technique used is dry etching with an etching gas. This picture gives an impression of the technology involved in this dry etching. All of the process steps we've seen, and many, many more, are repeated until the product has been fully assembled. This is what the smallest parts look like through a special electron microscope. Sometimes, the chip designers use a technique in which the chip is sawn through, so you can even look inside. The last step in the process involves making connections between the various elements in the silicon. These are so tiny that a minuscule vacuum-deposited layer of aluminium is required to make them. The innumerable processes, which take approximately 3 weeks to complete, are concluded by an initial visual inspection. Each chip is checked for a number of essential functions. After testing, chips which do not comply with the specifications are marked with an ink dot, so they'll no longer be used. Once they've been tested, the chips are ready for assembly. First of all, the slices are laid on a layer of adhesive film and then almost sawn through in 2 directions by a special, amazingly accurate sawing machine, so that the chips are almost separated. The slices are then carefully packaged and sent to the assembly centres in the Far East: Bangkok, Hong Kong, Manila or Kaohsiung in Taiwan.